Hello everyone, myself Anita, Assistant Professor, Department of ECE, Hindustan College of Engineering and Technology. Today we are going to see about keyboard and display controller 8279. So first of all, what is keyboard and display controller? It is specially developed for interfacing keyboard and display devices to 8085 processor or 8086 or 8088 microprocessor based system. The main purpose of this 8279 is it relieves the processor from the time consuming task like keyboard scanning and display refreshing. So the main features of 8279 are: first one is simultaneous keyboard and display operations. It performs both the operations, that is keyboard and display, simultaneously. Next one is scanned keyboard mode and scanned sensor mode. We will see in detail in later slides. So next one is 8 character keyboard FIFO. That is, at a time we can store up to 8 character in the FIFO, first in first out queue. Next one is your display is display 16 character. Next, the right or left entry is allowed in your display. Next, programmable scan timing. Now we are going to see about the block diagram of 8279. In this 8279 block diagram, the major 4 sections are keyboard section, scan section, display section, CPU interface section. Now we are going to see one by one. The first one is keyboard section. In this keyboard section, there are 7 written, that is 8 written lines are there, that is RL0 to RL7. In the bottommost block is written lines, that is RL0 to RL7. It belongs to keyboard section. It can be used to form the columns of the keyboard matrix. It has 2 additional inputs, that is shift and control / stroke. The keys are automatically debounced. Here, the 2 operating modes are there in 8279. The first mode is 2 key lockout, second one is N key rollover. 2 key lockout means if the 2 keys are pressed simultaneously, only the first key is recognized. In the N key rollover mode, simultaneous keys are recognized and their codes are stored in the FIFO RAM. So 2 key lockout means if 2 keys are pressed simultaneously, only the first key is recognized. In N key rollover, simultaneous keys are recognized and their codes are stored in the FIFO RAM. Here, the keyboard section, it has 8x8 FIFO, that is first in first out RAM. The FIFOs can store 8 key codes in the scan keyboard mode. The status of the shift key and control key are also stored along with the key code. So this is the general format of the scanned keyboard mode. The first bit tells the status of the control key, next status of the shift key. Next 3 bits are used to binary value of the row in which the key closure is detected. If you are pressing any key, the corresponding rows and the columns code will be enabled using this scanned keyboard mode. In a sensor matrix mode, the condition of 64 switches are stored in the FIFO RAM. If the condition of any of the other switches changes from the, then 8279 asserts interrupt request as high to interrupt to the processor. The first one is the keyboard section is over. Next we are going to see about the display section. So next one is display section. Here, the display section has 8 output lines divided into 2 groups. So, in this block diagram, see in the previous slide, so we see the display section. It has 8 output lines divided into 2 groups, that is A0 to A3 and B0 to B3. So, in the left bottom side, there is a display section. So it has 8 output lines divided into 2 groups, A0 to A7, A3 and B0, B4 to B3. So the output lines can be used either as a single group of 8 lines or as a 2 groups of 4 lines in conjunction with the scan lines for multiplexed display. Here, the output lines are connected to the anodes through a driver transistor in case of common cathode 7-segment LED. So in this display section, there are two modes are there. One is common cathode connection, common anode connection. Generally, there are two modes are there. Here, we are using common cathode 7-segment LEDs. Here, the cathodes are connected to the scan lines through driver transistors. Here, the display can be blanked by the BD line. Here, one line is used BD. That BD line is used to blank the display. The display section consists of 16x8 display RAM. Here, the CPU can read from or write into any location of the display RAM. Next one is scan section. So, in the scan section has a scan counter and 4 scan lines SL0 to SL3. So, in the scanned section, there are two modes are there. One is decoded scan mode, another one is encoded scan mode. So, in the decoded scan mode, the output of the scan lines will be similar to a 2x4 decoder. In a encoded scan mode, the output of the scan lines will be a binary count. Okay, so in the scan section, there are two modes are there. One is decoded scan mode and encoded scan mode. In the decoded scan mode, the output of the scan lines will be similar to 2x4 decoder. In the encoded scan mode, the output of the scan lines will be a binary count. And so an external decoder should be used to convert the binary count to the directed output. So in the encoded scan mode, we are using the external decoder. It is used to convert the binary count to the decoded output. Here, the scan lines are common for keyboard and display. These scan lines are used to form the rows of the matrix keyboard. So already we see that the written lines are used to form the columns of the matrix keyboard. So here the scan lines are used to form the rows of the matrix keyboard and also connected to the digit drivers of a multiplexed display. So next one is CPU interface section. So in the CPU interface section, takes care of the data transfer between the 8279 and the processor. The above part, that is the upper part, timing and IO control, data buffer, these are all come under CPU interface section. So this intersection is take care of the data transfer between the 8279 and the processor. This section has 8 bidirectional data lines, that is DB0 to DB7 for data transfer between your 8279 and the CPU. It requires 2 internal address lines, that is A0 equal to 0 or 1 for selecting either a data buffer or control registers of the 8279. If A0 is 0, it is used to select the data buffer. A0 equal to 1, it is used to select the control registers of the 8279. Here the control signals WR bar, read bar, chip select signal and A0 are used for read or write to 8279. Okay, WR bar, that is write signal, read signal, chip select signal and A0 can be used to write or read from the 8279. It has an interrupt request line, that is IRQ, for interrupt driven data transfer with the processor. This 8279 requires an internal clock frequency of 100 kHz. So these are all about the block diagram of 8279. The major sections in the 8279 are keyboard display section, display section, scan section, CPU and interface section. Okay, so next class we are going to see about the control word formats of the 8279. Thank you.